All right, this is all blurry. A continuation of our geometric notes or sequence and arithmetic sequence. So I ended this, and I apologize. This other one probably cut off, but this was your crazy amount. This is amazing how fast this grows. You started at a number of multiplying by 4. Well, you only do that 13 times. The 14th term, it is 335,544,320. That blows my mind. You just start with 5, you multiply it by 4 each time, you just want the 14th term. 335 million. This is why the formula is great, because I guarantee you would be worn out to try to write that, multiply that, and your error, you have a chance of greater chance of error. So crazy. All right, let's write this one. The equation for the nth term of the geometric sequence. All right, oh God, look at these numbers. So right away I notice it's negative, it's positive, it's negative. So I know I'm going to be multiplying. My ratio is going to be some negative. Now I need to see what's happening. Well, from 65 to 16 I might not see, but 16 to 4, this might be dividing by 4. So here's what I like for you to do is 65536 divided by 16384. Good, it's 4. But remember, you're not going to divide by 4. You're going to multiply by 1/4. So this is going to be a negative 1/4. Now, here's the thing. A lot of teachers will tell you to take the second term, but here's the problem with that. When you take the second term, you can do it. 384 divided by, because it's a ratio, 65536. It does a decimal, and I have a lot of students who type in decimals versus a fraction. Now, this one's probably not too bad. You probably know it's 1/4, but then I get people like 1.3 repeating, wherever the third one was, 1/3. They don't know that that's going to be 1/3. So I like for you to go ahead and figure out what it's dividing by, and then just use the reciprocal that you're multiplying. So this is going to be our negative 1/4 is your ratio. We're finding the 9th term, only the 9th term. So use your formula. So we're finding the 9th term in the sequence. Where's my formula? Our starting point is negative 65,536. Our ratio is negative 1/4 to the 9th power. It might be easier to, ooh gosh, you guys. I haven't taught you how to do 1/4 on your calculator, on your fractions. Okay, well, let's try to see this. Parentheses, negative 1. Now, if you don't want to do a fraction, you can do, okay, so this key, A, B, C, this one here is your fraction key on this one. Then 1/4, close parentheses. Now, you need that to be the 9th power. Wow, look at that. I knew it was going to be low. So negative 65,536, negative, oh my gosh, 0, 0. Oh, geez Louise. All that. 1, 2, 3, 4, 5, 5, 3, 8, 1, 5. Keep that in your calculator. Times negative 65,536. Oh my gosh. Really? Wait. Something's wrong. Oh, you know what? I didn't do 9 minus 1. Let's do the 8th power. That's wrong. 9 minus 1. Sorry, y'all. 9 minus 1. So that's the 8th. Now, here's another thing. Negative 1/4. If you don't want to do, you can do, you can do the decimal form of it. Now it's going to be negative. Negative 0.25 risen to the 8th power. That would be easier. Okay, so then times that by a negative 65,536. This is where you cannot multitask. Oh, yes, 1. Am I going to be a positive? Yes, I am going to be a positive 1. So the 9th term of this sequence is going to be 1. You started at a negative 65,000. You multiply it by a negative 1/4 8 times. 8 times itself, 8 times over and over again, and you get a positive 1. All those crazy numbers. Okay, so you've got to make sure you do 9 minus 1. I messed that up. I apologize. All right. So which one will you choose? Decide whether the sequence is arithmetic, geometric, or neither. Explain your reasoning and state the value of the common difference or common ratio. Give the next number in the sequence. So we have three things we're going to do. So the A, it looks like we're dividing by 2. Yep. Okay, so if you're multiplying or dividing, that's going to be a geometric. What is your common difference or ratio? Well, the common ratio is going to be 1/2 because you're dividing by 2. It's going to be multiplying by 1/2. And then the next number in the sequence, well, 15 divided by 2 is 7.5. And you can do a decimal or you can do a mixed number. All right, so here, 2 to 6, that could be times 3, but that doesn't work. What about plus 4? Ooh, but that's not plus 4. That'd be 10. This is going to be neither. This does not, it's neither because it doesn't have a common difference or common ratio. No common difference, nor, wouldn't that be nor? No, nor common ratio. So this is going to be neither. It doesn't add or divide or multiply times 3. Nope, that's neither. Okay, so let's look at these two. So we have 5 to 1, 3, 5 to 1. You can divide by 5 or subtract 4. Subtract 4, subtract 4, subtract. Okay, so this is going to be arithmetic, however you want to pronounce it. B, the common difference is a -4. C, the next number in line is going to be a -11. So our next term is going to be a -11. -3 to -12. Okay, so I can multiply by 4, or I can subtract 9, but I'm going to multiply by 4. Each of these, as long as 48 times 4 is 92. Yep, 192. And they're all negative. So this is going to be geometric. This is going to be the common ratio is 4. You're going to be multiplying by 4. And the next one then, 192 times 4. Now it's a negative, so make sure you have a negative. You don't need to put in a negative in your... Oh, did I already have that there? I don't know why 192 was already in there. It kind of freaks me out. Times 4, -768. So if you do, here's a negative. Like, just make sure if you're putting in the negative. Otherwise, you know a negative times a positive is going to be negative. Now we're going to apply this. You visit the Grand Canyon, which is amazing. You drop a penny off the edge of the cliff. Ooh. The distance of the penny will fall 16 feet for the first second, 48 feet the next second, 80 feet the third second, and so on. So I'm going to write this out. 16, 48, 80. So write a formula that represents a sequence. Well, here's our first number. Now what are we doing? Are we multiplying by 4? No. Multiplying by 3? 16 times 3 is 48. That's not, no, because 48 times 3 is not 80. So let's do addition. It's going up, so I'm either multiplying or adding. So 48, 32, yes. So that's going up by 32. So our common difference is adding 32 each time. Our first number, so we're going to use the arithmetic sequence. So go back to your notes to get that. I don't expect you to memorize these. Go back to your notes. So you have a to the nth. I'm going to just rewrite it here. A to the first plus your difference in -1. All right. So our first, so we want to know, we just want to know, this is our formula. So a to n, because we don't know our time yet. The first number in our sequence is 16 plus the common difference in -1. You can leave it like that, or go ahead and simplify it out, which if you distribute this 32, you're saying n 16 plus 32n minus 32. Combine like terms, 32n minus 16. Here's our simplified formula. Once I know how much time has passed, I can just plug it in here, which that's what I'm going to do. So after 6 seconds, I can do 32 times 6 minus 16. So 32 times 6, 192. 192 again. God, that number's haunting me. Minus 16 equals 1 176. So after 6 seconds, it has gone down 176 feet. Now, I don't know how big the Grand Canyon is, how tall it is in different places, but 176 feet after 6 seconds, it has gone down. It has traveled. The penny has traveled 176 feet. You could also, if you don't want to simplify it like this, you could also put it into the formula here, n minus 1. So that'd be 5, and then 32 times 5 plus 16. That should work. Hope that worked. Okay. A ball is dropped from the height of 500 meters. The table shows the height of each bounce. Okay. When you drop a ball, you know then it bounces, and then the second bounce, it goes lower and lower and lower. We're going to be doing some activities when we're doing quadratics, which is a lot of fun. So notice what's happening here. This looks like you can subtract 80. But subtract 80, that wouldn't be it. Okay, let's see what's happening here. Let's do 400 divided by 320. 1.25, that doesn't help. What's happening? Oh, okay, do this. Your second to your first, so this one does come out to where it'd be better if you did 300 divided by 400, that's 0.8. Let's see if this is the same. 256 divided by 320. Yes. 256 divided by 320, that's going to be 8. So what's happening is it's like decreasing 20% each time. So this is going to be 8/10. This is going to be a little bit harder. All right, so this is going to be a geometric. Go back, hopefully my time, yep, geometric. And we'll definitely help you. Where's my geometric sequence? It's such a mess. Here we go. So G of n, your first number is 400 times your ratio, which is going to be, 0.8. Then your n minus 1, because you don't know what your n is. I would just leave that like that. Then on this 6th bounce, here's the first bounce, the second bounce, the third bounce. We want to know how high the ball is on the 6th bounce. So we're just going to plug in G of 6 is 400 times 8/10. 6 minus 1. So you're going to take this to the 5th power. So getting this number, if that's difficult for you, let me know, and I will definitely help you with that. Oh, I should have left it in my calculator. That's right. 8/10 to the 6th. Which one is this one? To the 6th power, or no, to the 5th. To the 5th power, because we already have the first one. Okay, so that's going to be 400 times 0.32768 times, not multiply, or subtraction. Leave that in there, times 400, 131, about 131 feet, meters. Well, how big is this? Oh, meters. Okay, so 131, if you want to, 72, anywhere about 131 meters, 131.1, anything like that is fine. Okay, all right, so applying, knowing where you're starting, knowing the common difference or the common ratio, and then you're plugging into the formula. Use your formulas when you work on Delta Math, okay, or any practice that I've given you.